Hey. Yeah, can see right. Sorry about that. I think I didn't realize I put the PM. Good morning. Yeah, should be good morning, not the 10:30. 10:30 I'm going to sleep. How is the voice? Everything can hear? Everyone can hear? Okay. I should not. Okay, I don't put this. Okay. The volume is okay, huh? Perfect. Good. Sorry about that. Okay, let me see how many people are joining. Yes, today got 200. 205. So yeah, that's why I increase the mic, then they're very sensitive. I try to move my stuff away. Yeah. Now the mic is too sensitive. Is it okay? The volume? Oh, we need to wait for 3 seconds. Okay, I guess you all can hear. So today is the very first lecture for CE2001, CZ2001 algorithm. So basically I have two sections. The first half hour I will give you the course introduction, and in the next half an hour I will talk about the introduction to algorithm. That is the agenda for today lecture. Okay, that's my name, my email address, my office, and there's a second part is will taught by Dr. Kerr. Yeah, this is her email address. Yeah, this is her email address, office. Okay, then if you have any issue, because we have 700 students and we all have class, yeah, so if you need consultation, please write in email and arrange the appointment. Louder your volume. Cannot hear. Already increased the volume a lot. Still too. I hope the volume is okay. Okay, so yeah, if you need consultation, you write in the email, arrange the appointment. Likely now we should run in online appointment. Yeah. Yeah, so maybe some of you, your sides can hear loud enough. Yes. Yeah, good. Yeah, always whatever I respond, you find that it's 3 second or 10-second delay. It's normal. Whatever you put the chart, yeah, I only can see it after 10 to 15 seconds sometimes. Yeah, depend the network. Also depend the YouTube size. And this time I put the chart is like I put the slow mode. So you only can post the message every 30 seconds if I'm not wrong. Yeah, let's see. So what is this course about? Yeah, this course is basically teach you how to design the algorithm and analysis the algorithm. In fact, analysis algorithm is what, for my part, I'm more focused on analysis algorithm. So this module is not something like what you learn in data structure. It's not really the programming courses. So we not really require you to have no C programming, Java, C++, but you need to do the coding because you already taken the 1003 and 1007. So coding is prerequisite. You already know it. Yeah, so we will not teach you how to code, but you need to implement some algorithm in the example class. Yeah. So in the lecture and tutorial, we more focus on analysis algorithm and design algorithm. So this is kind of like, algorithm is kind of like a high level specification of the matter, how to solve the problem. Yeah, you're trying to outline the algorithm, the step, and then not really the implementation part. And yeah, so basically this is one of the important course in computer science and computer engineering. Yeah, that's why this is a core module. Yeah, so you can see your learning journey. Now you can reach this point, imply that you already passed these two programming courses. You already know how to write Python, how to write program in C, and yeah, so for object-oriented and software engineering is more on the implementation, and the algorithm database is more on the theory part. Okay, so not surprising, you can see that your algorithm, the prerequisite also including the max2 and discrete max. So you expect that mathematics is part of it. Yeah. So then after that, if you pass this module, then in the future you want to go further. 3007 still the core module for you. Then advanced topic in algorithm is another advanced courses in algorithm. Yeah. So you can consider if you're interested to know more about algorithm. In this module, I would say that is a basic introduction. Yeah. So, and yeah, that's why you take notes. We didn't teach you coding. You still need to know how to code in this module. Yeah, the data structure, we assume you already done. Discrete max, you need to expect that a lot of time you need to use a lot of mathematics here and there. Yeah. So yeah, so if you pass the algorithm after that, why you need to learn this? Computer network, yeah, they involve a lot of graph theory here and there. So yeah, you will use it, whatever you learn here, for in the future in computer network. Of course, parallel computing. In this module, we teach the algorithm is in sequentials. Yeah, of course, you need to learn this kind of sequentials algorithm first before you move to parallel computing. Yeah, to know how to parallel solve the problem. Yeah, using multiple processor or multiple thread, and so on and so forth. Then another area is the algorithm is in database. Not surprising, because you set out a database, you definitely need to do the sorting. You definitely need to do some query searching to search the data. So these are the basic knowledge you need to gain in algorithm. Yeah, so some of you are taking the database in this semester. Yeah, so these two can take concurrently. Then algorithm and AI. Of course, AI need a lot of algorithm to solve some real world problem. Yeah. Then you pass this one. You need to use a lot of AI. Definitely need to pass the algorithm. You need algorithm. You need a lot of mathematics to solve a lot of AI problem. Yeah. So this is also the prerequisite for AI. Yeah. So in this module, okay, maybe answer someone. What do we do? Okay, this one later I will explain. Yeah. Basic mathematics technique for complexity analysis of algorithm. That is like the next 2-3 weeks you're going to learn. Yeah, given you an algorithm, how do you represent in mathematics to represent its complexity, how complex, how efficient of this algorithm, which algorithm is better than the other one. Yeah, how do you judge what is a better, what is good algorithm? Yeah, so these are the things you need to, you cannot just simply said you feel that this algorithm is good, so it is good. So you need to use some mathematics techniques to analyze the complexity, the efficiency of the algorithm. Yeah, so this is the first 2-3 weeks you're going to learn. Yeah, after that, in the following week, you will learn a few algorithms and analyze their efficiency in searching problem, in sorting problem, in the graph problem. And we also introduce some classic difficult problem, so-called hard problem, MP hard problem, in the end of the semester. So upon this module, what you learn? Yeah, first you need to know, after this, if you can pass this module, that means you should be able to analyze or conduct the complexity analysis of some basic algorithm. Is there? Okay, basically they're struggling. Yeah, the first thing now I'm talking complexity analysis. Yeah, because involve the mathematics. Yeah, a lot of you maybe not that good in mathematics, so you need to quite quickly go and we're not going to revise your maths. We cannot always just keep going back to your year one, your O level, A level, then we keep repeat this thing. So we assume you have certain knowledge on all those foundation, yeah, mathematics foundation. Yeah, we cannot repeat all this story again and again. Yeah, so also you will learn a few strategy. Yeah, brute force algorithm, greedy algorithm, divide and conquer algorithm. Yeah, backtracking likely is in the graph problem. Yeah, so brute force is something like you really don't know which is the solution, so you need to try out all the combination, all the permutation, yeah, to find out the best solution, or yeah, the optimum solution. So that's so-called brute force. Greedy algorithm, in short, yeah, is always at the moment, based on whatever information you have, you always pick the best algorithm, the best solution, the best things at that moment, based on the information you have. You greedy, you always pick the best one at the moment. Yeah, but in the end it may not be the best solution. Yeah, so divide and conquer is trying to divide a big problem into 2 or 3 sub-problem, but with a similar algorithm. Yeah, so you're trying to reduce the problem size to smaller and use the same algorithm to solve the smaller problem. Then eventually you merge all of them, divide and conquer the problem. Yeah, so backtracking is like you first go and search before you make a decision. Yeah, you keep searching until you reach certain point. Yeah, you find that this is the path you need to move. Then you start backtracking and then come out the path. Yeah, so that is so-called backtracking. You will encounter in the graph traversal later. Yeah, heuristic is like, yeah, you're trying to make some assumption here and there, if yeah, certain condition, adding some constraint to solve the problem. Yeah, this you will encounter in the end of the semester. Yeah. So okay, for my part, I will cover the first 4 weeks. This module is very interesting. I cover the first 4 weeks. Then after that, I will come back in week 12 and week 13. Dr. Kerr will cover from week 5 to week 11 for his sorting and graph traversal problem. Yeah. So this is the schedule. So basically today is just the introduction to algorithm. The revision, I just quickly scan through the things for you. But you really, if you're not really good in mathematics, you really need to spend some extra times to start to revise all your O-level maths, A-level maths, or engineering maths to your discrete maths. Yeah, you will use some engineering maths too, material. Okay. Yeah, analysis of algorithm. We will cover in the next 2 weeks. Then week 4 we cover the searching. Then Dr. Kerr will cover the sorting for 3 weeks and graph traversal for another 3 weeks. Then I will come back to introduce what is those basic computability theory, something like MP. You may heard about this in computer science, very classic problem we call MP hard problem. Yeah, we will introduce those problems here. And then in week 13, will be a revision. Tutorial will be start from week 3. Yeah, the question is already available in the NTU Learn. You can go and take a look. For the example class, yeah, this times is different. Have to take notes. You only have 2 projects. Will be bigger project. Okay, example class. So you depend your group, either it's even week or odd week. Yeah, you will come to form the group, brainstorming with your teammate, and then the next after two weeks later, you will do the presentation. Yeah, the details we will let you know in the coming weeks. We will release the project to you. Similarly to the project 2. Yeah, so this time only have 2 projects. But we have an assignment. We still keep the midterm test, but there's no final exam for this module. Very important, there's no final exam for this module. No final exam. So there's only one midterm quiz in week 8. Yeah, likely will be conducted in the tutorial section. Yeah. The detail we will let you know soon. Okay, this is part-time one, I skip it. Okay, in the NTU Learn, there are some online learning fair lamps, yeah, which is done by previous faculty member, so the lecturer, so we just reuse it. Don't worry, it's not graded. It's mainly for you to practice. And that the form group issue, the lab supervisor will let you know. Yeah, we try not to let you yourself form it. Okay, we will try to introduce some randomness. So yeah, so these things is not graded, very important, not graded. Don't worry, you can go and just keep trying. I suggest you can go and, after you go through the video, the lecture and the lecture notes material, yeah, you should try to do some self-assessment to test your understanding. Yeah, so this is a good material. That's why I don't want to grade it. Yeah, so it's trying to let you go and learn whether you understand the concept or not. No exam. Yeah, there's no exam. I think the system didn't update properly. Yeah, so actually we can't, our class size is too big. We won't be able to conduct any exam in this semester. Yeah, we only can, we only can run the quiz, which is 30%. At this moment, we only plan for one quiz only. I cannot say for sure we only have one quiz because this COVID-19 measure may change anytime. Yeah, if there's a second wave, third wave, whatever, yeah, then we have to adjust the assessment. But if no any unforeseeable circumstance, I also hope that we only have one assignment, one quiz, 2 example class. So that means 15% each, 30% for the one quiz, and 40% for your individual assignment. That one will release maybe in the next few weeks. Yeah, the submission for your individual assignment should be in the week 13 or week 14. Yeah, detail again, we will let you know soon. You don't worry about it, okay? The quiz is mainly let you understand test your understanding. Then if I give you the answer, yeah, then it's end up you just read the answer again. That meets the purpose. So I don't think it's a smart way to release all the details for you. So if you have difficulty, you can try to discuss with your friends, with your tutor, or me. If you find out that all their explanation is still not satisfied, you can just send me an email. And normally I tend not to tell you I think some of you already asked me the question. You will find that I didn't tell you the answer directly. Normally I tend to give you some hints, some guide to let you yourself figure out how to do it. Because I tell you the answer, the step, you just know how to do that particular question. You also not being surprised I won't ask that question in the quiz again. Yeah. So these are the textbook for this module. Yeah. So you can try to refer this. Among these, personally, I think this book is quite classic. Yeah. Yes. So this is the algorithm. Yeah, I think how thick it is. It's about this size. Yeah. It's a kind of a Bible by the Comment. This is an introduction to algorithm by Thomas Comment. Yeah. I think all these book is available in the library. Yeah. So this is the course about. Let me see. The assignment is lab or report. Likely is a report, kind of a report base. Yeah, it's not the lab. It's an individual do it at home. Yeah. So I think more people concerned about this. Then okay, assignment will release soon. Maybe we will release the example class first. Example class problem first. Then after that the individual assignment maybe not so soon. Maybe will be, because the submission is in the end of the semester. Yeah. It's random. I would say that it will be decided by your lab supervisor. Yeah. Okay, good question. Since you scared to write the essays, that means I also scared to mark your essay question. But we need you to practice something, right? Yeah, something you're not good at, something you're good at. And why we still want to train you in those things you are good at. Yeah. But we also consider, that's why we haven't decided yet, because always need to consider we got 600-700 students, and you write 500 words, you need to think about it times 700. That number is scary. No, example class is how to say, is a project. Example class actually is a project. So you will work in a group, but in the end, of course you somehow need to work at home of sorts. Yeah, but the presentation is done right now. The plan, we're trying to let you done the presentation in the lab. Yeah. So example class is during the lab section. Yes, but it's more like you expect that the first section is trying to form the group and do the brainstorming with your friends. Then you can split the task to your friends, your teammate, and then some of them may be working on the coding part, some of them trying to write the report, some of them maybe do the presentation. Yeah, the detail will let you know soon. So, but yeah, you expect this semester you only have 2. If you check the previous semester, we have 4 example class. So this time we reduce to 2. So the project will be trying to make it more challenging. Yeah, because only 2 projects. Yeah, because we introduce the assignment this time, and no final exam. Yeah. So next, move on for the introduction to algorithm. Can tutorial be recorded? That's subject to your tutor decision. Yeah. If your tutor want to record, want to make it online, and then everyone comfortable with it, yeah, maybe that group will go for online. Because my intention is not record the tutorial, because no different. I give you the solution and I record a video, then you watch the video and then find out the solution. Yeah, that will miss the purpose to have a tutorial. So introduction to algorithm. So at the end of this part, we're trying to explain what exactly an algorithm is, and we'll show you some simple example to let you see what same problem we can have different algorithm to solve it. Yeah, including the summation function. I think I already updated the slide. I think I make some mistake. Yeah, in the old version maybe don't have this. Yeah, I will try to introduce another Fibonacci sequence here to let you have a better picture about this, and then some sine function. And later you can watch it. In fact, now you are watching the YouTube. The live one will always record. Yeah, So state the criteria, choose, how you select the algorithm, how do you decide this algorithm is good or bad? So, okay, what is an algorithm? Okay, if you go and read the textbook will tell you that an algorithm, in the introduction to the design and analysis of algorithm, okay, they tell you that our algorithm is a sequence of unambiguous instruction for solving a problem and obtaining a required output for any legitimate input in a finite amount of time. So that means your algorithm should not have some unambiguous, unclear, undefined instruction. That means something, you said very, very big or very small. Good, bad, this kind unclear, it's very unambiguous. Everyone read your algorithm will interpret very different when they implement, they won't be able to implement the same program to the end user, because you have some unambiguous, everyone will interpret very different. That is one thing. Your algorithm need to take notes when you design the algorithm. Another thing is like finite amount of times. That means you must complete all the program cannot run infinity. There's no output, you need to wait forever. So must be done in a finite amount of times. Of course, your output must be correct. Not surprising. You give whatever output, you give whatever input into this program, they should generate the same and correct output all the times. That's so-called an algorithm. So in the common introduction to algorithm, an algorithm is any well-defined computational procedure. Must be well-defined computational procedure, and they take some value, some input, set of value, input, and then produce some value or set of value or as output. So in general speaking, first you must have a clear set of simple instruction to follow and can compute a function. So there's something like you're trying to make the cake, and the step must be clear. Each step, the instruction must be well defined. There's no any unambiguous instruction inside. Then the step order must be clear. Step 1, step 2, you need to put the whatever things at step 1, you need to, it's always in the step 1. So all this must be defined clearly. So, okay, so a good algorithm, of course, it must be correct. That means it must be able to always generate the correct output. You give whatever input, it always give you the correct output all the times. Okay. Another issue is it must be composed of series concrete steps. So there's no ambiguous as to the step performed to the next. So step 1 do this, always the next one should be step 2. You cannot be sometimes step 3, sometimes step 2. So a good algorithm process the following property. The next one, third one, is finite step. You must be correct. All your steps must be clear and well defined. And then third is it must be complete in a finite step. That means if you only have S step, it's a finite. There's no infinite loop in your algorithm. Otherwise the program forever you won't get the output. That means there's no correct output in the end for your program, or you need to wait forever until 100 years you still cannot get the output. That's definitely not a good algorithm. So in the end, it must be terminate, so that you can get the final output. So roughly that is the good algorithm. Always you start, and in the end you can reach the end point. You won't stuck in a certain loop forever, cannot get out. So what is the difference between computer program and algorithm? So when we talk about a computer program, actually it's just an instant of an algorithm in some programming language, Python, C, C++, Java. That means I got a problem. Today you have a problem, you want to solve it. First, actually is trying to design the algorithm first. And this algorithm you have not implement as a program. You can select, depend your application, depend your requirement. You can use Python, C, Java, C++ to write the program. Then that program is just an instant of the algorithm. Yeah. Then that means the programming means that it contains some for loop, while loop, if else statement. Yeah, all the steps must be follow the syntax of that particular programming language, and then that program can be compiled and can be executed to get the right output you need. If you provide the certain input to the program. So this process is called implementation. You're trying to turning an algorithm into a program. We call it implementation. So when we solve the problem, we're trying to design the algorithm, and then after that we're trying to implement the algorithm into a computer program. So that is the difference between when we talk about computer program and algorithm. So for example, now if I want my problem, this problem I want to I want to solve the problem. What is the summation from 1 plus 2 plus 3 plus 4? This arithmetic series from 1 plus 2 to plus n. This become my problem. I need to design an algorithm to solve this problem. So how to do it? There are a lot of ways. Algorithm for a programming language may not apply to a different language. No, algorithm is nothing related to programming language. That's why here there's no for example, this now I give you these three algorithm. There's no any, and it didn't represent any programming language. Maybe the third one you can say it look like Java, it look like C. But it's still not really, because he didn't. You can see where got any programming language got n is 1. So it not really represent any programming language. So a lot of time you got the algorithm, you still need to try. After that, you still need to kind of like so-called implementation. That's mean you need to understand, then trying to implement according the language you use, the programming language you use, the syntax, and then write the code accordingly. So the first one, we want to sum, very intuitive. It's like you just initial a variable called sum as 0. Then after that, you run a for loop. Every iteration, you just increase your I, then you add your I into the sum. So it's 1 plus 2 plus 3 plus 4 plus 5. So you can just simply run a for loop, keep adding the I into the sum. So in the end of this for loop, in the finite step, n step, you can get the answer. So there's no any unambiguous instruction in this algorithm. This algorithm can be complete in finite step. And I think it's quite clear. It definitely generate, always you give whatever n, they always give you the same output, and the output should be correct. You can set that is so-called the pseudocode somehow. Another way, if you have learned the arithmetic series, you should know that this is the formula. You got n term. This arithmetic 1 plus n, so total got n term. So it's n over 2. The first term is 1, the last term is n, so it's 1 plus n multiply n over 2. So this then even easier. You just one line solve the problem. Then third, some you probably in 1007 you have learned the recursive function. You can write this thing in recursive way. Then that's when you're trying to solve this m plus 1, m1 plus 2 plus 3 plus 4 plus 4 plus 5 to plus n. So that means it's like n plus the summation of n minus from 1 to n minus 1. Then the problem becomes smaller, then become n minus 1. Then use the summation from 1 to n minus 1. Then the next recursive call is like trying to n minus 1 plus the summation of n minus 2, and so on and so forth. So eventually your n will reduce to 1. At that time you start return. Then it's 1 plus 2 plus 3 plus 4. Yeah. So in the end, the final return will be the summation from 1 to n. Yeah. So which is the most efficient? Yes, that's a good question. I'm going to ask. Among all these, which is the most efficient one? 1, 2, 3. Can someone reply me? Someone said. Okay. We have right now we have 383 people inside. Let's see how many people. Someone can respond. Usually longer run times. It's very hard to say which one is longer or shorter. If L4 loop, yeah, depend the also that's why it's depend on the PC also. Depend on the programming language you implement. Yeah, there are a lot of factors. Good. At least there are two. Good. Yeah, answer is 2. Very obvious. One line only. The other two, one use for loop. The other one use the recursive function and then keep recursive call. And you also not surprising that the third one actually use more memory, because every time you recursive call, the computer need to store a lot of stuff in the stack memory temporarily, because later when you return back to the recursive call, they need to return back all this, recover all the things you stop before the recursive call. Yeah, so you expect that the third one actually is the least efficient one, and the second one is the most efficient one. Detail you will learn it later. Yeah, so next is the Fibonacci sequence. Have you heard about Fibonacci sequence? I guess you should learn it in discrete math. Yeah. So basically, the Fibonacci sequence is like 0 plus 1, the next number will be 1. Then 1 plus 2, that's the next term, 3. Then 2 plus 3, the next term will be 5. Then 3 plus 5, the next term will be 8. And so on and so forth. Every time you just sum the previous two number, and then you will get the current term. So to implement this, I think this is a very classic recursive function. So one way is write it in recursive function. Yeah, if n equal, the base term is actually the 0 is a 0 term. Normally you can ignore. So this is 2 base term. Yeah, so when n equal to 1 or n equal to 2, you just simply return 1. Then after that, you want to look for other term. Yeah, the third one will be the first one plus the second one. So you will use a recursive call, n minus 1, n minus 2. Yeah, you just keep recursively call it. Yeah, this is the recursive solution. Of course, there's another way. I can write it iteratively. That means I try to initialize, I try to create 2 temporary variable and then assign it as 1. Then every time I just sum these 2 temporary variable, I will get the next number. Then the loop will keep updating the 2 temporary, will just shift the temporary number, and then to calculate the new number, the next term, and so on and so forth. After n iteration, yeah, after the more precisely it's n minus after 3 to n, so it's n minus 2 iteration, you will get the answer. Yeah, that is the n term in Fibonacci sequence. So algorithm 4 and algorithm 5, among, yeah, these two, which one more efficient? Yeah, algorithm 4 and algorithm 5. Compare these two, which one more efficient? 5, 4, 5, 4, 5 more. Yeah. Yes, yes, okay. Okay, most of you answer is 5. So yeah, actually 5 is more efficient because you can see that your n, if you look at this thing, let me show you the pen. Yeah, if I got a Fibonacci is 4. Actually, when your input is 4, you need to recursive call F3 and F2. Then in the F3, you need to further to call it one more time, F2. Fibonacci recursive function F1. Yeah, then you can return. So just a recursive call is already 1, 2, 3, 4, 5. You already need 5 function call. But this one just one iteration. Yeah, just one for loop. Yeah, you got n, you just run n times. But you find that this one, later you will cover this thing. Later, you will find that, yeah, the number of call is 1.68 power to n iteration. Yeah, so the efficiency will be much higher. Back to okay. Next, discuss. Yeah. Okay. So next, maybe another example. So how we compute the size function? Is there any advantage to recursive beside the algorithm? Normally, is recursive function a lot of time is more intuitive. Yeah, when you're trying to solve certain problem. But generally speaking, nearly all the recursive function can be converted to iterative version. And normally iterative version, sometimes you maybe need to use more memory to store some temporary data. But doesn't mean recursive function don't need, because every time you recursive call, actually you also use memory. Yeah. So I think it's more related to the implementation. Yeah. And when you come out the idea to solve the problem, I think recursive, in certain type of problem, you prefer to use a recursive way to solve the problem compared to iterative solution. You will encounter some problem, you want to convert it to iterative function, it's not easy. By storing and referring the trigonometric. Okay, one way, I don't know whether you still use this kind of table. Yeah, when you cannot use the calculator to find the sine function or cosine function, tangent function, you will refer this kind table to find out the answer. Yeah, so if you want to implement your sine function in this way, not surprising, it's very fast. You just make up a table, then you give me the input, I can quickly go to the array to search the index and then return the answer to you. But not surprising, this one need to use a lot of memory to store this data, but the response is fast. Yeah. So another way, you probably learn this thing in engineering max 2, Maclaurin series. Yeah, then you just use this formula, implement this formula. Because computer got limitation, you don't really need to do this thing infinity. Up to certain term, you basically can stop already. Because yeah, the error is already too small that your computer won't be able to represent it. So maybe 10 iteration, maybe 20 iteration, maybe sufficient. Yeah, so you just implement the 10 factorial, x power to 3, x power to 5, x power to 7, and so on and so forth. So you can find that this one involves some for loop here. Computation definitely is not cheap compared to the previous one, but this one don't really need a lot of memory to store. Yeah, so yeah, you just implement it, then you can get the answer. That's another way. Yeah, this probably is those scientific calculator, the internal how they implement those sine function, cosine function. Another way, in this one is developed, I also don't know, but it's according wiki, they told me it's like in 1958, people design, want to calculate the sine function to aim for the bomb to shoot they need to adjust to calculate certain the angle, so they need to use this method. It's an iterative approach to calculate the sine function. You don't have to fully understand what this thing means. In short, it's always start from V0 here, start from this point, then they always rotate certain amount. Then if you rotate over more than beta, then they will start change the direction. Yeah, then they will keep switching from V0, then to V1, then V2 is overshoot, then they change the direction. They were trying to move back, then forward, backward. Then eventually he converged to beta, then that is the sine beta. So yeah, just for your information, this is the formula, the algorithm, to calculate the beta by this Codex approach. Well, that means there are a lot of ways to calculate. In short, this is not the purpose I want to cover here. I just want to let you know there are a lot of ways to calculate the sine function to solve this problem. Yeah, and then which one is more efficient? A lot of time you also need to consider efficiency is considered about the times or about the memory. Sometimes depend your resource. If you have limited memory in this particular application, especially people working in CE, people working in embedded system, you don't have so much memory. Yes, certain algorithm is more efficient. You can calculate very fast, but they need to use a lot, just like the table one. It's very fast. Just look up table, then return, immediately get the answer. But you don't have so many memory to store the data. So this means that sometimes you need to consider the times and the memory resource you have. Sometimes you want to work it in real times. Resource is not an issue. Then of course you will choose the most efficient in terms of time. So how do we choose among the different? Yes, so this is in short what I'm going to say. To design, okay, so people working to design an algorithm that's easy to understand, to code, to debug. This is the job for software engineer. If you're talking about the efficient use of the computer resource, memory, the times, computational times, so that is the more theory. You can think that the first one is more application people, then the second one is those people working in theory, in research. We are looking for the efficiency. We want to get a good algorithm, meaning that they can run using shorter times, using lesser resource, memory resource to solve the problem. That involves people working in data structure and algorithm analysis. Software engineering is talking about how to modularize the things, then so that easy to debug, then the reusability and so on and so forth. So when they more on working on implement the algorithm into a program. Then the algorithm analysis is trying to find a better solution, yeah, to let it run faster or use lesser memory. So different role, playing different things. So, but in this course, like I said, we more focus on the analysis part. Yeah, we will introduce some algorithm later by Dr. Kerr about in sorting and graph traversal, but we still do the analysis among all those algorithms. Yeah. So implementation wise should be module you will learn in ODP, object oriented design and programming, and software engineering, and those module in 3000 and 4000. Yeah. So one of resource. So okay, near end of today lecture. So today at least after that you know what is the algorithm, what is the difference between computer program and algorithm. You know that one problem can use many algorithms to solve it. And in this module, you're going to learn how to select them, how to judge which one is a good algorithm or which one is the most appropriate algorithm for your application. Yeah. So that is today's lecture. Thank you. I think so far we have 380, about today got 380 students attend. Yeah. So, any question? Yeah, if not, I think okay lah. I'll just let it run till another 4-5 minutes. If you have any question, you can post it in the chat. Or if you shy, you can just send email to ask your question to me, also can. Yeah. Yeah. So the I think since this thing is working fine, so I think we likely to carry on to use YouTube at this moment. Yeah. Then yeah, I will put I will take notes the timing. Yeah, should be 10:30 morning. Yeah, sorry about it today. Okay. If no questions, seems everyone start leaving. No how long does it take to finish 2 example class? You have about 2 weeks time to do your example class. So the group currently we plan for 4 to 5, about 4 to 5. Yeah, it's a group of 4 to 5 students. So the work should be done in 2 weeks times. Yeah. So that is the plan. Yeah. How much time, how long? Yeah, of course not the whole 2 weeks you work on that particular project lah. But yeah, how to score well? Yeah, the thing you need to study lor. Yeah, we try to make as random as we can. Yeah, but that decision is up to the lab supervisor. So the lab supervisor will take a look. Yeah, will decide it during the lab section. Yeah. So I suggest you all go and take a look this. Yeah, if you not sure whether you still remember all this. Yeah, I would say this lecture 2 I won't cover it. So if you want, you can go back and take a look. Anything you not sure, you should go back and find your mathematics, whatever notes in your poly, in your JC, in your engineer 1000 module. Yeah, do the revision. Yeah, you will use all these series, geometric series, arithmetic series. I update I think should not be 0. I think I should put 1. Should be the first term and the last term. I suggest if you don't blindly memorize those algorithms, should go and derive it once, then to have deeper understanding, okay, each term what does it means. Yeah, that will be better. Which And if YouTube, the probability YouTube goes now compared to our NTU Learn, I think is much lower. And then if that is the case, the worst case, I backup plan is using Zoom plus Microsoft Teams. That's mean one times I open, in fact I already get ready, 2 microphone, 2 webcam, everything in pair, 2 slide, 2 computer, everything run in pair, then 2 room, then we can occupy 600 students. But I hope not the case, because control 2 PC parallel is very tough. At the same time, I need to give a lecture. Yeah. So what is the recommend study plan? There's so much info. What are the info? First, I would say that my suggestion is like you don't have to print out the lecture notes slide. You just need to print out these short notes. Basically, all the things I want to cover is inside this kind PDF, the notes. Yeah. That one also switch, but I didn't use that too much. Yeah. Can investigate. That one I also able to stream it out through that channel. Yeah. But I hope not. They better don't server now during my lecture times. Yeah. Then save my times to work on those things. It's not easy. You need to monitor so many things at the same times. Yeah. Recommend page. Yeah, I suggest you just need to read through those slides. Lecture 1. Yeah, actually all these things I cover is already summarized in this thing which I want to cover today. You can find out the full details. Yeah, in fact it's much more clearer. I can make some animation. Out of the 30, create your own in fact, you find that every time you work on you solving the problem, you are create the algorithm. Yeah. So if you didn't solve the problem, that means you didn't work on solving problem, that means you are not working on design algorithm. Is there any estimate that no addition? Estimate when we will know the addition information for the quizzes. No, quizzes right now the plan is in week 8. Yeah, temporary. Currently the plan, if there's no any other event, unforeseeable event happen, yeah, we probably only stick with one quiz in week 8. That's it. Yeah. So the quiz if you're asking about the format, I would say that it's in any format we want to test you. I would say it's any format. I don't want to give you it can be mixed, can be MCQ with the short answer, long answer. Yeah. But it's probably only 1 hour tutorial. If it's run in tutorial class, the tutorial section is only 1 hour. Yeah. Can we form our own team? Definitely your team is from the same group, but will it be totally random or in what format? The decision I left the lab supervisor decide. If the lab supervisor want to randomly pick, he have the right to do that. If he want to let you form it freely, is also the decision on their hand. Yeah. But my intention is trying to make it some randomness, yeah, to make it a little bit fair. Okay, the last 1 minute, I will end this stream. 226. Any more question? Sometimes I may miss out your question in the chat. Yeah. So don't feel sad. You can just send me the email again. I can answer you separately. Yeah. Okay. Last 10 seconds, I will shut down. Okay, thank you and goodbye.